Hi, everyone. Thank you for joining us for today's webinar, What's New in FEMap 2401. My name is Jonathan Hill. I am a business development engineer here at ATA Engineering, and I'm coming to you from our Northern Virginia office. I am very, very excited to be joined by Andy Haynes from Siemens Digital Industry Software for today's presentation. Andy has been with the FEMap development team, I think, for over 25 years. So he's a great resource, and again, I'm very excited for him to be here and appreciative of his time. Before I turn things over to him, I would like to give just a quick intro to ATA Engineering for anyone who might not be familiar with us. So ATA Engineering offers high-value engineering services focused on test and analysis-driven design. We are very passionate about helping our customers overcome their toughest multidisciplinary product design challenges. And we have experience doing just that, supporting customers across a wide range of industries, covering everything from aerospace and defense to themed entertainment and more. We are an employee-owned small business with a staff of just over 210, split across 7 nationwide offices. And we have decades of experience with everything from structural dynamics, thermal analysis, and vibroacoustics to fluid dynamics, multiphysics simulation, and more. We're also the leading independent modal test group in the United States. So we have a lot of experience, shipping out our equipment and flying out to wherever the test article is, whether that is an aircraft or a spacecraft or what have you, conducting a modal test and then bringing the data back and using that to correlate our finite element models. We are also able to leverage our experience, supporting all these different industries and our different clients through our role as a Siemens partner and value-added reseller. So in that capacity, you can come to ATA to license really powerful tools like NXCAD, Teamcenter, and the simulation tools within the Simcenter portfolio. Now, the Simcenter portfolio includes FEMap and Simcenter Nastran, which we'll be focusing on for today's presentation. But there's a lot of other really powerful tools in there as well, including SimCenter 3D, StarSystem Plus, AimSim, HEEDS, which offers really great optimization. And then most recently, ATA became the first and only US reseller for Siemens test and measurement solutions. For all of the products that we support, we encourage our software customers to reach out to ATA's software support hotline for any problems or things like that. The cool thing about our hotline is that it's actually staffed by engineers who are using these tools every day for our services work. So when you reach out to us that way, you're getting in touch with an engineer who is familiar with the tool. They have practical experience from their day job, if you know what I mean. And so normally they're able to help overcome those challenges, day of. And then I also like to point out that ATA offers a lot of different training, including FEMap and Nastran training. And we actually developed the official Nastran training material for Siemens. After today's presentation, I would invite you to check out our website for a lot of great information. In addition to, product brochures and things like that, I think the website is probably the easiest way to get in touch with our technical support hotline. And you can also find calendars of upcoming events and seminars and things like that. And really, maybe the best part of the website is our free resources. So we have a large collection of other on-demand webinars and FEMap APIs, white papers on super elements and things like that. So there's a lot of great content out there. I'd invite you to check it out after the presentation. Please also let us know. We like to create content that is useful to the people that will be consuming it. And so we're always looking for inspiration for new webinar topics or API, things to accomplish with an API that would make your lives easier. So let us know if you have any ideas like that. With that, though, I, again, am very excited to have Andy here. So Andy, it's all yours.
All right, just let me share my screen here.
Perfect.
And share. Can everybody see?
Yep.
All right, perfect. So without further ado, we're going to get on with this. And as Jonathan said, thank you, Jonathan, for the introduction, and thank you everybody for joining today. I've worked with FEMap since I started working at FEMap in 1998, and I've done everything here other than physically write the code. But I've given a lot of these type of presentations. Really enjoy feedback from customers and that sort of thing. So without further ado, here we go. So we're going to be talking about what's new in FEMap 2401. So 2401 was released in February of this year. We're also then going to release a maintenance pack. Just so everybody knows, we're basically bringing out 2 releases a year. 2024 is going to be a little different. So we are going to bring out 2401, 2406, and then 2412 instead of going to 2501. That's just to better align with some of the other products in the Simcenter portfolio. So again, 2401's been out since February. We plan to have a maintenance pack for it in March or April. And just for anybody who's currently using FEMap 2301 or 2306, we will be bringing out MP4 of 2301 and MP2 of 2306 sometime this month, probably, hopefully next week. And just know that these actually do contain quite a few fixed issues. So, I mean, if you've been having any kind of trouble with 2306 MP1 or 2301 MP3, these should help you out on that front. So what was new? The first thing we're just going to talk about is managed environments. And what we're really going to talk about is Teamcenter Share for a bit. So we added support for Teamcenter Share in 23. It was either in 2022.1 or 2021.2. But anyways, Siemens Accelerator Share is now called Teamcenter Share. So all we really did for on this front was just change our interface to our user interface to match the names. So again, instead of being called Siemens Accelerator Share, it's now just Teamcenter Share. So in the various places where that was mentioned in FEMap, that's been updated. Now, all that said, we are really going to be working on a higher level of Teamcenter integration moving forward in the next couple of releases. So just be on the lookout for that. In terms of geometry, we did not do a whole lot. Again, obviously we already have the Parasolid kernel inside of FEMap. We updated all of the geometry translators in our previous release, 2306. So all those should be up to date, and you should be able to use CAD from using our direct interfaces from pretty much the latest and greatest of all the types of geometry that we support. But what we did add was we just added an add matching holes to the pick menu for the standard any selection dialog box for curves. So basically you can just pick one curve, and if it matches, essentially if it matches the radius of that curve, it'll just go find them all. And where can this be helpful if you're using a command like geometry surface remove hole, or some of the defeaturing tools in the meshing toolbox. Again, you can use that especially when you're doing kind of the multi-select with the standard any selection toolbox. Sorry, dialog box. Pre-processing. The big thing that we added for 2401 just overall was the Layup Builder. What is the Layup Builder? It's a new dockable pane that you can be used interactively to create any number of layups using kind of an intuitive table control. It's accessed by the tool's Layup Builder command. And I'm going to do a demo of this. So I'm not going to go through all these slides, but I am going to go through a few of them just to start off with. So basically you have a couple of options. You can make a new layup stack. You can create a layup stack from an existing layup, or we can attach to a composites HDF5 file. And currently the HDF5 file that we connect to is from Fibersim, another Siemens digital industry software product. But it actually works with a number of other CAD systems as well. So that's the way that you can create them. Depending on when you've read it in, or how or what you're doing, basically you can kind of get different columns that'll show up. So when you do read the HDF5 file, basically you just select the file, you see if the scale factor matches, and then you get a preview of kind of the ply locations in the graphics window. Once you have saved one of these layups, you can always reload it. You can delete it. You can send the information over the clipboard. You can send it to Excel. Just a lot of functionality that exists in our other dockable panes. You can choose columns if you want to kind of control a little bit more about how the Layup Builder is going to build your layups for you and properties. There's kind of this icon that you can click that'll take you to Layup Builder options, and then you just have a number of options that you can pick for composites HDF5 options or just layup creation in general. So again, you can kind of tweak what it's doing, but hopefully we've picked a bunch of defaults that will help out 95% of the time. So, but again, if you just need to tweak, you can go in there and change some things. All right, so what I'm going to do is I'm just going to go over in the Femap, and I'm just going to show you a little bit about this. All right, perfect. Okay, so here we go. Sorry, so again, you would go to Tools, Layup Builder, and again, it works like any other dockable pane in Femap. The first thing you can do is you can just make a new layup stack. So again, that's just going to make you a one row at any time. You can add a couple of additional plies to the layup stack if you want. Here's where you can pick materials. You can pick whole kind of columns, and then just say, I want to just pick a material instead and set it for all of them. You can do very similar things with thickness. You can kind of just be like, oh yeah, constant thickness, something like that. And then of course, you could enter your various ply angles, anything like that that you might want to do. I kind of missed that one, but okay. You can also specify an orientation direction. So you can just say, hey, I want to specify a fiber direction. So I'm just going to specify my fiber direction for these to be along the x-axis of the global rectangular coordinate system, which is going this way. And I'm just going to say, okay. And then if I want to, I could specify it here, or I can actually just kind of click on this one here and say, hey, use this ply to set the material orientation for all of my elements. So I'm just going to do that. So once I have that, then I could basically come here to build layups, but I can't quite do that yet because I still haven't selected anything over here. So what you can actually select is you can select elements, you can select surfaces, or you can select groups. And you can actually do a combination. So like, let's even say I did select elements and I got these, just said okay. Then I can also come in here and say select surfaces and pick a number of surfaces as well. All right. So then you can kind of see over here in entity selection. So I would need to do that for each one of my rows, but I can have different selections for different rows, and by doing that, that's what's going to make me my different layups and properties automatically inside of Femap. Now, without doing that, what I'm going to do is I'm just going to open up one that I already have created here. So just going to do reload edit stack. Yep, just going to clear the grid. And what we have here now is essentially, I can also specify, I didn't really mention it, you can also specify global plies. You can specify titles if you just want to use a row or not use a row when we're actually creating the layups and properties. You can choose to include it or not. But again, once you have it kind of all set, and you can kind of see, if I come over here to like preview the mesh, I can see which elements are going to be used for which plies. So a lot of what you might have heard of this type of thing is this is also sort of called zone meshing inside of any sort of layup builder type of command or what have you in other products. So you can kind of just see what's going on. You can, so right now I have exactly one property in my model and I have no layups. But once I'm all set to go, again, I can hit this check ply info button. And what I'll get is I'll get this errors column. And let's just say I did not have something defined. Like, let me just say that thickness was 0. If I were to do a check here, it's gonna tell me, hey, I found an error. I can come over here. I just highlight it over, and it just tells me what the problem is: an invalid thickness, but it could be an invalid whatever it might be. So there's a number of different things, and just as you kind of go up here, you can kind of just see what you have in the row. So let me just turn this back to 0.1, and then I'm just going to finally, when it's time to go, I just do build layups here. This is going to say, okay, to update the model. It created 3 properties and layups for my 480 elements in my model. So I'm just going to say yes. And then if I wanted to, the easiest way to do this type of thing is just do the properties, do color, and then just say random. And then we can kind of see our various sections that it created automatically. And it did that via 3. Sorry, it made us 3 plies. What I'm going to do is I'm also going to show you this other command while I'm in this particular model, which is we also added the model laminates add plies to mesh command. So if I want to, I can just say, hey, I want to add plies to all these layups just based on the elements that I select. So I'm just going to select a couple down the middle here. And I'm just going to use Control Shift pick to start my polygon pick. Hopefully everybody on the phone knows that. If not, again, that was a Control Shift and click to start a polygon pick instead of using the pick menu. But once I do that, I can just add a ply. So I'm just going to add another ply here. And what this is going to do, I'm just going to add, another ply, and I can just pick an angle. And let's put a different one in there. And then I can add plies. I can add a ply material if I have that specified. Again, a ply material is something it's kind of a different entity than regular ply. We introduced it in 2301. So basically it has a material defined and a thickness defined to it. And it also has a ply failure theory if needed, or we could actually just insert a whole other layup into here. But what this is going to do is this is just going to add it to the top, or I can add it above a particular global ply. That's what I'm actually going to do. I'm going to just add it on top of, my middle global ply that I created with the layup builder here. And now you can see I actually have 6 properties and 6 layups, because what it did was it just made me new layups by adding that one ply. And again, if I were just to, kind of do random colors here, now I can kind of see where my different properties and layups are specified. All right. What I'm going to do now is I'm going to do something different, and this was sort of why we started getting into the layup builder in the first place. One was the way I just showed you, so you could just automatically make layups, but another was, again, to read this information from Fibersim. So what I'm going to do is I'm going to just do attach composites HDF5 file. It's going to come into my go. And I'm just going to pick this H5 file. It basically detected that the units in my model and the units that I have set for geometry scale factor are different. So I'm just going to actually say no here. And then I can kind of see, it gives me this nice outline to see what's going on. Basically, that's where it knows to create the layups. Okay. Once I'm done previewing, I can kind of see that I actually got a couple of extra columns here. I actually got these composites HDF5 columns, which includes component information and layer information from the Fibersim file. Maybe that's important to what you're doing. That's just all up to you. But you can also see that my material says from composites HDF5, same with my thickness, and same with my orientation information. So the fiber angle and direction are all coming from there. And if I did want to change this information over here, I just have to come in here and just say allow edit of the composites HDF5 columns if I wanted to change that for any reason. Now, I could start adding stuff to this if I wanted, but that's kind of not the whole point of this. But we're really trying to use the data from the Fibersim file as best we can. So what we can do is we can actually decide to show the component, just an outline of the component, or what we can also do is just show the ply fiber direction. And I'm just going to kind of zoom in here so we can see this a little bit better. So all that was read directly from my Fibersim HDF5 file. Now, once we have that and we're all set and we know it's in the proper location, what we can do then is we can actually, instead of, again, if we wanted to, we could start selecting elements. If we had surfaces or groups, we could select that. But the better workflow to use here when you're trying to use the Fibersim data is to just use this select mesh from composites HDF5 ply info. And basically I could pick any portion of the model. In this case, I'm just going to pick it all. And then if I want to, what I could do is I can just come in here and again, I can just kind of see where my various rows are going to be used to make layups. Now, in my other case, I made three layups in 3 properties. A lot of times with the Fibersim, what you're going to do instead is you're going to do something like build layups. And you can see it made me 1,179 properties based on my settings that I have in here, and, for my 1,311 elements. So essentially, it basically almost created one property for every element. But again, to get all the angles correct and everything of that nature, you can certainly do that. So I'm just going to say yes to okay. Look at the model. I could then, kind of take a look here. And I'm just going to highlight my first one here. And you can see, like in this case, up here on this flat section, it was actually able to consolidate those all into one property, because when it made that layup, it was just able to do that on that particular portion of the model. So, so that's what this can do for you. And then now that you're kind of all set up here, now is when you could just apply your loads, boundary conditions, etc., and run your model. So let me just go back to the PowerPoint. And I will send this whole presentation as a PDF to Jonathan to send you guys. Oh, one of the other things that you can do is you can also just do a preview of the element layup. So you can basically just go pick an element from the screen once you've kind of assigned which elements should be used by which row. And then it'll actually show you a preview of the layup. You can also just say, hey, I just want to select the rows with a particular element. Again, you just pick an element and it'll show you which rows are going to be used for that element. So, and that'll even happen before you use the actual build layups command. And then these are just some of the other things I showed you. And then again, this is just some more detail about what each one of the columns is and what each one of the context sensitive menus is. But we don't need to go through that here today. Again, just a little bit more about the model laminates add plies to mesh command. Again, you just kind of pick and choose what you want. You can also, I didn't really mention it, but you can also do the layup symmetric, anti-symmetric if you want, when you add these plies to the mesh. Okay, again, I kind of demoed that. Okay, so the connect fluid region command displays this fluid region dialog box. And what we're going to talk about is incompressible fluid surface. Basically, what we had before, we always had support for the virtual fluid, which is used to specify options and entities written to the M fluid entry. Essentially, that's one where you just kind of put, you just tell it which sides of shell elements are wetted, and that type of thing. But new to it was Simcenter Nastran 2312 was this ability to do incompressible fluid surfaces. And essentially what this allows you to do is collect sloshing modes from your analysis. And again, this could be used in something like a fuel tanker, or probably more so what the folks at ATA would be doing is fuel in like a fuel tank for some sort of spacecraft. So again, you basically can come into the fluid region. You basically just give it the faces that you want to say are the free surfaces of your incompressible fluid surface. You can say whether the free surface allows sloshing, and you can put in gravity. And if you're going to do component mode synthesis reduction, you can also just give it the number of modes that you want to use to be able to do that. And this is just kind of a version. This is kind of what you would typically do with this. The structure would typically be plate elements. The fluid itself would be solid elements. And then the region is the faces of the solid elements. And we're going to get into a little bit more about what you do with this when we just talk about the updates we made to the analysis set. In meshing, we didn't do a whole lot here, but just know that we added in the last. I was talking to Jonathan actually before this. I mean, in the last 3 years, we've added both the body mesher and the hex dominant mesher to Femap. So if you're not familiar with those, I would suggest you can always just reach out to Jonathan and he can tell you about them, or you can go look out on the internet for things about the body mesher and hex dominant mesher in Femap, and you should find some videos. But the one thing that we can do is that if you're using the mesh geometry surface command to size for meshing, we have an option in here for surface interior mesh growth, which we were not honoring before. But again, now if you just turn on the quad or the tri-mesher and turn off the map meshing options, what you can do with a quad mesh is basically you can kind of see if you have the mesh size set there on the left. If you don't have a growth ratio, it comes out like that. If you do have the growth ratio, now it's being honored. So it's just a nice way to take advantage of just making less elements away from the features of note in your geometry. Performance improvements. If anybody's watched since one of these since 2301, you know that we've been doing stuff with the United Graphics Architecture, or UGA. Just so everybody knows, Femap contains these 3 different pipelines currently, which is original OpenGL, performance graphics, and now this new unified graphics architecture, which is on by default. The drawback with having these 2 pipelines is that some entity types only kind of work as expected in original OpenGL, while others were not supported by performance graphics, but performance graphics was much faster. So essentially it can be a little confusing. Once this new unified graphic architecture is completed, it will be the single pipeline, and the other 2 will be removed. Okay, so that's the entire idea. So for 2301, and that was the first implementation, and then for 2306, we kind of got ready to add what we're going to add for 2401, and we will be adding more in 2406 and 2412, and hopefully we'll get pretty close to it being fully done by the end of the year. We also just kind of turned the name into a dialog box. So now there's this unified architecture dialog box. So you should not go in here unless you're seeing a problem when using the unified graphics or unified architecture option. You just want to always have all this turned on because it's using the correct OpenGL version. It's right, and basically everything that's supported by it is turned on by default. But if you see something not working as expected, here you can kind of just turn off entire groups of things. So let's just say you just wanted to do geometry the old way, you could turn that off, or the geometric loads or the constraints, you could turn them off, or the nodes, that type of thing. So what's currently supported by unified graphic architecture? Coordinate systems, all geometric entities, geometry-based loads and constraints. And what was new for 2401, this is big, was nodes have been added to it. And this includes support, as far as we know, for all display options for nodes which previously existed in the other 2 pipelines. By all means, if you see something strange with nodes or notice some kind of change in behavior, absolutely let us know, or let Jonathan know and the good folks at ATA. But anyways, we're just moving forward with that. In terms of analysis support, kind of an oversight on our part was basically if you highlighted an analysis set in, say, the model info tree, we didn't put anything into the entity editor. Right now, as a first step, we just started by adding some information about the title, which solver you're using, what analysis type, the results destination, and then also if you currently have set a portion of the model to write. So essentially, that's just going to tell you if you're currently writing out the entire model or if not. And again, this is something that we plan to add to moving forward. I highly doubt we're ever going to put all of the options into the analysis, into the entity editor when you pick one of these, but it certainly could be used kind of at a higher level, maybe, and especially to provide a little bit more information than this, say maybe at least, be able to change your boundary conditions or something of that nature for your particular case, or again, we're still weighing exactly what we're going to do there. So when can you use this incompressible fluid surface? You can use it in normal modes or modal frequency response. So again, the defined fluid mass approach is, just more useful when trying to make a complicated fluid volume shape. Again, I kind of showed you that you could do it in a fluids, just by making a incompressible fluid surface type of fluid region using connect region. And I'm just going to kind of come over here, back over in the Femap. I think I need to hit escape again. Actually, can you guys see the screen?
Yep, we can see Femap.
Okay, good. So just so you can kind of see what's going on here, let me just close the layup builder. We don't need that anymore. So essentially what we have is we just have some solid elements down here. Again, the tank would be shell elements, and then we have a fluid region up here. Now, what do you want to do when you want to post-process this? The first thing you're going to do, and this is explained later, but would be you would actually use import analysis model, and that's going to actually bring in a number of plot-only plate elements, which I'll just kind of show you here. Let me just turn off the region. So just basically Nastran creates these, and then we read them in. But why do we need those plot-only plate elements? Because we need something to post-process on. So then once we have that, we could just pick any of our sloshing modes, and we can see, animate, the various sloshing modes that we might have. So just something to think about. And this was new, and again, the folks at ATA helped out tremendously, helped us scope that entire project out. Along with everything that we did in terms of making the fluid regions, we also added this whole incompressible fluid options section. And again, I'm not going to go through all of these, but it's basically whether you want to activate these. And then there's some fluid structure interaction modeling and fluid structure interaction control options that we also added that can be specified to really make this type of analysis do whatever you might want. In terms of helping out Solution 401, hopefully someone if anybody was using Solution 402 with a recent version of Femap, you notice that we went from having multiple dialog boxes to having a single dialog box with tabs to set up the strategy parameters, the N, L, C, and TL2 for Solution 402. Well, we did the same thing for Solution 401 for 2401. So now everything is just now on various tabs. You're only ever in this one dialog box. There's now buttons to just do the default values for a tab, or default all for all of the options in this, which didn't exist before. And some of it's been just reorganized into topics, sections that just make a little bit more sense. And if you're looking for a little bit of a map from where it was before to where it went, this slide will tell you kind of everything you need to know. Another nice thing about it, well, sorry, we also added a few options that were added for newer versions of Simcenter Nastran. So a couple of options for solution 402. We also changed a few defaults, and then we changed an option for solution 402 as well. So again, and these are Simcenter Nastran's multi-step structural and multi-step nonlinear kinematic solvers. Abacus. So again, the whole idea here is to allow Abacus users to work in a more familiar environment when setting up their analysis. So we're starting to use more terminology, methodologies that you might see in other pre and post processors and in the Abacus solver itself. So now when you make in a new Abacus run, you're always going to get an initial step. So that's just where you set default constraints, connectors, initial conditions for the analysis. And then it's also automatically going to make step one, which is where you would set other boundary conditions, such as loads, your options, and your output requests for each analysis step. And then you can create any number of additional steps by just basically clicking on it, like clicking on any step and saying new. So this is just kind of what you would have gotten before. Everything would have been in global requests and conditions, which is much more of a Nastran idea than an Abacus idea. So now it basically breaks it into initial step and then various steps. None of the dialog box, for the initial step, the dialog box can now be, this just didn't even exist before. And what you can also do is set up, contact sets and glue sets up here, along with the other stuff I said. You can also do, as for the analysis step, and Abacus step options and output requests, these dialog boxes are the same that they've always been, so nothing has changed. So if you're familiar with those, and the only other real thing that we did here was you can actually change by adding steps and using this new dialog box here, you can now change which contact sets are used for which step in your analysis, which you could not do through the FEMap user interface before. So that was kind of the big thing there. And just to show you, this type of analysis, like a rubber seal like this was always possible to do in FEMap before. It's just, I just don't know how many folks have used Abacus, but if you are using Abacus, again, all this was possible for. We're just trying to make it a little bit, more user-friendly for Abacus users. And before I go on to anything else here, I just wanted to show you that this was one piece of functionality just on the geometry front in the meshing toolbox that we slipped into 2306 kind of at the last minute, but it might help you. Say you have a kind of a fillet like this where you can't, it can't just be removed. It kind of has to, it just needs to kind of, but you still want to get rid of it to simplify your model. What we actually have now is we actually have this command to extend to a surface. We're going to extend a surface and we're going to make it planar. So we had something very similar, but you actually needed a surface in order to do it before. Now you can kind of just have it go to a plane. So you could just grab, say, these two surfaces, and then just say I want it to be along this global plane. And what that'll allow you to do is just get rid of that type of fillet, which you really couldn't do before very easily in FEMap, unless you had kind of a surface to extend it to. Post-processing, again, pretty much the only thing we did for post-processing was we added the ability to read in plot L elements from a Nastran file. We just have support for that now in general. And again, we did that specifically for the sloshing modes so we could visualize them. Okay, kind of coming to the end here. A little bit about miscellaneous. Again, I'm just going to come back in here to FEMap. So we implemented the command finder in 2301. Then we improved it quite a bit for 2306. And we've actually now done this even more so for 2401. So now, like as you type, things will become available. If I want to, and I just kind of go over here, it'll now pop up where the command is directly in the user interface. If there are, I mean, it's already also describing what's going on, like kind of where to find it here. If you just want help for a particular command, you can just come here and it'll just take you directly to the help, you know, directly to the Femap help for that particular command. And also we kind of added this one thing at the other, you know, just kind of, hey, maybe just go search online for this. I mean, I probably wouldn't, you know, it's going to specifically look for Femap items, but you know, it's certainly something that might help you. So anyways, it's just another tool to try to make things more discoverable inside of Femap. I'm just going to go back to the PowerPoint here. To try to make licensing a little bit easier, we added the help manage licensing command. So this actually allows you to change your licensing method for Femap at any time. I'm not sure if this, how many people this applies to, but especially if you're going back and forth between, especially at large organizations, if you're going back and forth between, say, a subscription license that maybe your organization has purchased for a little while and like a regular floating license, perhaps, there's just a number of, you know, this is just an easier way to do that. You actually would have had to close Femap completely and go use one of the go underscore .bat files that was in the Femap install directory before. Now you can just pick your now you can just pick your licensing type, depending on if you pick your licensing type. You might have to specify new stuff like license location. There's just an entire section here that is just has a lot more info than before. This also allows you to switch to the bundle. The bundle is actually now a product available for Femap. Well, it's a Simcenter product that actually allows you to run Simcenter 3D and Femap from a single feature. You still have to have Nastran set up, but it certainly may be helpful. And then, especially if you've been using the subscriptions, you can just kind of pick and choose what you want here. Some other nice features is at the top, you either get a green, you either get a green circle like, hey, you're connected, or it'll tell you, or it'll be red and tell you, hey, you're not connected. And the whole idea here is to give you a little bit more information about where you're getting your license from. So that's the big thing there. There's also ability to kind of just browse to a particular file location. You can actually have it generate a fully qualified domain name, which is actually more important these days than we thought it might be. We actually kind of have to even use one here at Siemens sometimes to get to some of our licensed servers. And then there's also a test connection button, which will just perform a ping of the server machine. I mean, that's all it's really doing, is just doing a ping currently. But you really do. Sometimes you just need to know if your machine can see the server machine. So that's what that'll do for you. And then down at the bottom, there's a show modules and show users button that'll just kind of show you, which modules you have, seat count available, and when it says show users, it'll also show you who in your organization is using those licenses. In terms of API, we just added support for all those things that we added for like the incompressible fluids, for solution 401, for making the fluid regions, and then just added a few other things here that people asked for, and then some other options just for the unified architecture for the new preferences. So that's it. So looks like we got a few things in the chat here.
Yeah, thank you so much, Andy. I can read in some of those chat questions if that would be helpful for you. I'll throw back up contact slide real quick. Okay, so everyone should be able to see that again, but let me pull the chat back open. In the meantime, yeah, we would welcome additional questions. So you can put questions in the chat or the Q&A tab. And then just let me know too, if you would like to unmute, and I can give individuals permission for that as well. But Andy, maybe to start off with a question from Brian on the API. And he is looking for the ability to automate analyses, basically use code to define a model and then run analysis. Um, he notes that currently the API has no idea when the solver has completed, which means you can't iterate a design using code to converge to an optimum design. So is that something that might be coming to API soon, or can you think of a workaround for that?
Yeah, there's actually an entire events section at the end of the API manual. You can't really you have to be able to track events, which you can't really do through the through our API programming window. But there are such things as using the quote unquote event callback is also another way to do this, and that you can actually use that through the API programming window, or just by launching. But there's an entire set of events that are in Chapter 6 of the API manual, like analysis end, results read in, all sorts of things like that. That I think that's where you should be able to use that type of information to be able to do like an iterative analysis. There's also, I mean, you can also just write if you just want to queue up jobs, you can just use the analyze multiple inside of Femap if you have the analysis sets set up. But I mean, it sounds like they wants to change items each time, and so we do have that ability in the API. You just have to be able to have your application do event handling. So and I know that can be that is a little bit more advanced, but I mean, if you have something that can do that, you should be able to monitor and track events.
Would that work with like Python too?
I that one I can't answer you right off the top of my head, but I will certainly find out for you.
Okay, thanks.
Yep.
There's also a question, and this might be sort of bigger than like FEMAP or even Nastrian specifically, but kind of couple or like a question, I guess, related to layups. And do you have any suggestions? I'm sort of paraphrasing the question here, but do you have any suggestions on how to verify, you have like an analytical representation of a layup? Like, is there a way to verify that is that is behaving the way we would expect it to behave?
Other than looking at the results, we don't have anything currently that would be doing that. I mean, just that's really up to the analyst. I guess I guess I would ask for like what type of criteria are you looking for to know if it's modeled correctly? It's not. I mean, layups and composites in general. I mean, now just have to tell everybody before anybody asks. Femap is still not doing any draping or anything like that for laminates. Okay, I mean, Fibersim might be doing it and then giving us that information that we were reading from that HDF5 file, but we still are not doing any draping or making rosettes or darts or anything of that nature. So just want to make sure that nobody thinks that that's really what we're doing with the layup builder yet. But I mean, no, we need some idea of which criteria you'd be looking for to know that your layups are modeled correctly.
Okay. Yeah, and Brian, if you want to just ping the hotline with that question, I don't think I've seen you ask that one. So if you just want to ask the hotline, and maybe folks there would have other suggestions, or at least be able to, ask around internally a little more. I will try to do that as well, but you can follow up with the hotline yourself as well. All right, continuing through. In Simcenter 3D 2312 release, there was an added function, force limited notching. Does FEMAP have a similar functionality or plans for a similar functionality?
For force limited notching?
Yeah.
No.
Okay. And I think that would also, I think that might be something, Sean, I'm not sure if you've heard of ATA's Vibrata product, but that's sort of like a dynamics toolkit that takes in a Nastran modes run, and you sort of interface with it through Femap. But Vibrata lets you do different dynamic simulations, and I believe Vibrata does have force limiting as a part of that. That's sort of how ATA does force limiting a lot. So maybe you could check that out. Feel free to reach out if you have additional questions on that. Had a question if we could get a PDF of your slides, and Andy, you mentioned you could send those to me, and so
Yep.
I will post those on our website. So yeah, we'll get PDF slides out. And then maybe the last question for now, unless others continue coming in. But the question on, does FEMAP and Simcenter Nastran support HDF5 file outputs? I know there's been some stuff over the last couple of releases, but Andy, could you sort of summarize HDF5 support, and maybe I think there's a Simcenter equivalent?
Oh, yeah. Well, I mean, so we support the HDF5. We support HDF5 output that Simcenter Nastran puts out. Specifically, we had to add support to be able to support rotor dynamics, because their output was only coming out in HDF5. We also support it when it's created by Simcenter Nastran and other places. If we are missing anything and you notice that we're not supporting it, please let us know, or please let ATA know. But we added support. We added HDF5 support in 2306 for Simcenter Nastran, and then or it might have been 2301, and then just and further implement it in 2306. And then we also fully support the HDF5 file that is created by MSC Nastran now as well. And that one is actually very well baked and very, and as far as we know, we are supporting all the output in it that we've had, that we've looked at. So now the other thing to know about our HDF5 support, whether it's well, especially on the output side of it, like I just mentioned, all the structure, all the architecture is now in place. So adding additional output vectors is quite easy. So again, if you notice that we aren't supporting a particular type of output or a particular output vector that is in there or is coming up in the FO6 file, again, just let us know, and if you can, and then we can certainly dig into it and add to it. But again, now that we have the baseline done, and it's really easy to add additional output types, vectors, etc.
Awesome, thank you. Maybe last question, is there a more detailed tutorial video on how to set up the sloshing analysis? And I guess doesn't necessarily have to be a video. I think, is there either anything in the FEMAP help or maybe the Nastran documentation?
We actually, you know what? We actually made a what's new video that kind of explains how to set up the sloshing. So I can certainly make that available. Jonathan, I can send that to you. I believe it goes through kind of all the steps that are needed. It does not go into, I can tell you that the video, because it's supposed to just be kind of, hey, this is new functionality, does not go into depth about what you need to specify in the analysis set manager per se. But can always, we actually do have an example model we could provide as well, which is just a kind of a simplified tank structure. So if somebody just wanted to use that as a template, maybe that maybe that would go a long way in helping them out.
Yeah, perfect. If you can send that to me or just point me to it, I can make sure it gets through to Mark.
Yeah, absolutely. And I will send you that. I will also send you that video. And actually, yes, somebody actually put in here, yeah, Babak basically said, we do have the ability, we do have the ability to show A, B, and D matrices calculated through FEMAP for laminates. So there's actually a calculate button in the Layup Manager, and that you can also just turn on the info. Well, actually, how much time do we have left here?
You're good. Do you want to take the screen back?
Yeah, give me the screen back, please.
Yeah, please take
And
it.
yeah, so what we could do here is if you turn on this entity info
I don't think you're
dialog
sharing yet.
box. Okay, sorry. Oops. Oh yeah, I didn't share actually. Oops. Share screen. Yeah. Let's just share the screen. Share. Okay. Can you see it now?
Yep.
Okay. So what you can do is you can come in here to tools, entity info. All right. And then now now that our layups are built and all that good stuff, what you can actually do is you can come in here, you can do modify, edit, layup. I'll just pick one of these. And yeah, you can just compute the layup overall properties. Okay. So when you click this button here, compute overall layup properties, essentially what it does is it listed all this information to both it listed it here to the messages window, but you can also have it just once you hit the calculate button, when you add, remove layups, again, it's calculate. It'll show you what's being calculated for the A, B, and D matrix, and then the inverse of those. And then you'll also get some information down here, like the membrane properties, if that made sense for you, or the bending flexural properties. So yes, sorry, I didn't really think about this. Yes, I mean, that might be one way to help you verify that your layups have been specified correctly, because this information is typically available. And let's just go back in here to. Oh, and back to Gary's question. Yeah, the HD. Yes, we are supporting HDF5 output, and it's been in the works for like 4 years now. There was initial, and I can tell you this. There was an initial implementation of HDF5 output, but then kind of went through a different approach. And the whole idea of the HDF5 file for output that we're thinking of for Simcenter Nastran is it's not just for Simcenter Nastran, it's actually for all Siemens products, simulation products, I should say, that that have this type of output that you might find in the HDF5 file. So hopefully, when they're all done and completed the project, you'll theoretically be able to take output that was created by something like Star CCM Plus, and then we could then, because we're already reading the HDF5 file that Siemens is creating, we could then just figure out which output vectors that we might want to use, and then we could go from there to actually using it as output theoretically in FEMap, or even perhaps using it as input. Because most of the time, I mean, I don't want to say most of the time. Some of the time, you might want to use the output you're getting from something like Star, and create loads with that in FEMap. So again, we now have the ability to read the HDF5 file being created. It's just they just sort of need to finish it off over on our end, and it's just going to introduce a whole bunch of kind of new functionality that will allow the various products over here at Siemens DI to talk to each other a little bit better.
Awesome. Yeah, that'll be great.
Okay.
Cool. So I think that wraps it up. Thank you everyone for joining. Andy, thank you so much for the presentation and demos and answering our smattering of questions. Yeah, so I will get the recording up. I will try to follow up with everyone who reached out with questions. So with that, thank you all. Please feel free to reach out after today. If you have additional questions or anything, just let us know. And otherwise, I hope everyone has a great afternoon. Thanks, everyone.